Hey guys, it's Nick, and I'm just going over fatty acids today. So, hello, and fatty acids are carboxylic acids with I think it's 6 or more carbons. It might be 9. So, just a basic structure would be, let's do this. So there's an oxygen. Imagine that's an O. There's an OH. And then this is one important part. This is just going to be a long chain, Boop, boop. At least 6. I'll just do a bunch of them. So okay, now we have a fatty acid. Important things. Just the first thing you want to remember is this is carbon 1 right there. That's carbon 1. You think it's part of the carboxylic acid, but when this connects to pretty much whatever the residue would be on, it could be anything, like a phospholipid. This will be there, but you have to remember count from the carboxylic acid carbon. This is not carbon 1 right there. That's not. So that's one important thing to remember just when we're naming these. So I'll go. This here is, first off, another thing to remember is in a fatty acid, if you have a double bond, it will be cis if it's a natural fatty acid. So the naming configuration for pretty much everything kind of assumes they're cis, and then if they're trans, you have to say otherwise. So here we have this one. There's a bunch of different kinds of nomenclature. The first is colon nomenclature, which is kind of also combined with delta nomenclature. So here, the first thing you'd want to do is just count. Let's pick a color. Let's go R. Oh, I should do it like this. Black. Sorry about that. And make right-click orange. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 carbons there. So in colon nomenclature, this one's gonna be real simple. We have C10 colon 0. This is just the number of carbons, and the 0 is the number of double bonds. So there you go. C10 colon 0, real simple. The problem with this nomenclature is, say I said to you, okay, draw C. I'm gonna make it easy on myself and do C9 colon 2. If I tell you to draw that, there's 2 double bonds, but you don't know where they are. So they came up with delta nomenclature, which is a variation of this. So you have C9 colon 2, and that's great, but you want to know where the double bonds are, so you get, I can't type a delta, so I'm just going to type D, or what looks like a delta, A. That A is going to be a delta, just for us. So it would be A3, comma, 3 to 4, 4, 1, 6. The reason I was doing a little bit of math is because the bonds in fatty acids are very, very rarely conjugated. So this would be the double bonds between 3 and 4. Then you have 5, and the double bonds between 6 and 7. So if this is a delta, I'm going to make it a little bit smaller. And that's not noticeably smaller. Oh well, so there you go. C9 colon 2, delta 3 comma 6. So we want to draw that. Start out. I'm not going to put the oxygens in, just because it makes it easier. So that's carbon 1, 2, 3. We have a double bond. Remember, it has to be cis double bond. So that's 4. Carbon 5, carbon 6, double bond. 7, 8, 9. There you go. This is, like I was saying the double bonds are normally not conjugated. So this is delta nomenclature and colon nomenclature, but they end up getting combined. Now another, let's call it popular nomenclature, is common names. So for a lot of fatty acids, they have common names that people use. I'll go through them at the end, but so this is not one of the ones I know the common name for. C12-0. So if that was C12-0, that would be lauric acid. Like I said, I'll go through them and draw them all later, but just so you know, there are common names as well. The last nomenclature system that is really used is the omega system. So this bases the name. It's based on, you've always heard, omega-6s and omega-3s and fish oil is good for you and don't eat so much red meat and all that. So it's based on the omega system for naming the fatty acids. And the easiest way to do the omega system is, I also don't have an omega. Obviously, I don't have Greek letters on my keyboard. So we'll use an O for omega. That makes sense, right? So you take the last carbon and you count backwards. And that tells you how far back the double bond is from the end of the carbon. The last carbon will tell you if it's an omega-3, it's an omega-6. Those are the big ones. So like here we have 1, 2, 3, 4. So that would be omega minus 4. And this one does not have a system to tell you where the double bonds are. But like I said, you normally know because of the way the conjugation works. How it's not conjugated, it normally has a carbon in between. And that's because of how the fatty acids are typically formed in the body, why you have that pattern. Okay, so now that we kind of know the different types of nomenclatures, I'm just going to run through some common names of them and their symbols. And I'm just going to get a new, whoa, it's orange. Okay. I didn't expect that. Okay, there we go. So, common names for them, and some ways I remember them. So, the first one we'll do is lauric, which is C12-0, and it's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. There's lauric. And that's C:12: fail. I promise you I can type. So C12-0. Also, if there are no double bonds, it does not have an omega nomenclature. So this is lauric. And all of them are going to be acid. I'm not going to type it just to kind of try and save some space. So there we have lauric. The next one, these are just some common ones. I remember that because Laura, like lauric acid, Laura, is 12. I don't know why that works, but you think Laura, think little girl, and that makes you think 12. Also, unfortunately, the ones I had to know tended to be no, smiley face. Basically, they just tended to be evens and no double bonds, and then a couple with double bonds. So C14 is my ristic acid. I hate how hitting enter doesn't place it. Okay, and I'm not going to draw that one out, but basically it's going to be the same thing with two more. And remember that is your wrist is, if you can remember, either myristic or palmitic, which is the next one. And if you remember kind of going out your arm, obviously you get to your wrist first. Myristic is C14-0, and palmitic is C16-0. So, I guess it won't be too hard to draw these real quick, so I'll do it anyway. So that's 1, 2, 3, 4, 5, 6, 7, oh my gosh, 8, 9, 10, 11, 12, 13, 14. And it's the Himalayas now. So palmitic, so remember that's carbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So there you go, that's palmitic. The next one is steric, and steric is so big that it gets in the way of everything. Like your steric hindrance, not really, but there you go, C18-0 is steric. And all these are acid, like I said before. So that's going up. Just kind of the ones with no double bonds. Lauric, my wrist, my palm, and then steric because I use my fingers to steer the car. And it goes wrist, palm, steer, and then you have to remember that Laura is 12. So that one I'm not going to draw because that's just a ton of carbons, and it's not going to be that helpful. So now into more interesting ones with, basically with double bonds. This one's kind of like a little family. The first one is oleic, and so this one is C18-1. And like I said, you're gonna have to bear with me on the A. That's a delta, and it will be 9. This is another thing. 9, 12, and 15 are where the double bonds normally are. So this is oleic. Just drawing that real quick. Boom, boom. Nope. 1, 2, 3, 4, 5, 6, 7, 8, 9. Double bond. 10, 11, 12, 13, 14, 15, 16, 17, and 18. Okay. The next one in this family is linoleic. You'll notice obviously the name's the same, or almost the same. And it is C18:2. Delta 9, 12. So, there's oleic. Oops, sorry about that. Another thing you can do is oleic is an omega 9, or omega -9. But so all the different names for them kind of coming out for these. This is linoleic, an omega 6. And just to draw it, because I like torturing myself. 1, 2, 5, 6, 7, 8, 9 to 10, 11. Here's the pattern again. You'll notice 9, 12, 15 will make this pattern. 15, 16, 17, 18. And the last one in the pattern is linolenic. And I bet you can never guess what the carbon's going to be for that one. I'm just going to assume you guessed right because obviously I can't hear you. And we'll go, it's C18-3. And I gave it away before what it's going to be, but it's 9, 12, 15. And like I said, there's more common ones. The next common name I'm going to go over obviously breaks the rule, because why would I tell you a rule that works? Oh, and that's an omega-3. So remember, the O's are omegas, the A's are deltas. And for this one, now I'm doing it tiny. 1, 2, 3, 4, 5, 6, 7, 8, 9. Put the double bond in. Put the double bond in at 12. 15. Oh, it didn't. So 16, 17, and 18. There's an omega-3. Now the last one I had to know for my class, and therefore the one that I can tell you is it's not part of this family. That's a 3-oleic, linoleic, and linolenic, and they kind of demonstrate the 9, 12, 15 pattern. The last one is, and I have no idea how to say that, arachidonic acid, but this was just kind of our class's example of an omega-6 acid. It is C24, and I'm actually going to draw it at the bottom, but yeah, I'm going to draw it down here, but I just wanted to put it up there so I didn't take up all my space. Like I said, this is going to be an omega-6, and this one you'll notice is weird, because based on that, where the bonds are, you're going to think, oh, it's going to be, 9, 12, 15, 18, but it's actually not. It's 5, this one's 5, 8, 11, 14. So I'll put that in there. You will notice that the pattern with it being every third, so you have the carbon in between, so it's not. Oh, that makes me angry. So imagine the delta is up there. That's the delta. So we're going to draw this one and see if I can get it right. So there's the carboxyl group 1, 2, 3, 4, 5, double bond, 6, 7. So there's our not conjugated version, and wow, these look really bad. I'm not an artist. 15, 16, 17, 18, 19, 20. And that should be omega-6. 1, 2, 3, 4, 5, 6. It is. So, there's the common name, arachidoic acid. Other than the common names, you do run into some other things, but the easiest way to know if you have to draw something you don't know is just, it's C, number of carbons, colon, number of double bonds, and then delta, where the bonds are. So I just said 12, so I'll just say there's one at 9. And this is kind of an important thing. If there's, in order to say that's a trans double bond, which is not commonly found in the body, I believe there are a couple, but they're a little bit unnatural. Trans is kind of what you get in trans fatty acids and everything that is also apparently horrible for you. So you get a little lowercase t after it. And even if you don't know the common name, obviously you can still draw them. And I'd never give myself enough space. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have to do a trans double bond so I can go down. 10, 11, 12. There we go. So that would be that one, and that would be an omega-3. So, anyway, that kind of concludes the overview of naming fatty acids. Common name, which is just the name people use. There's C, colon nomenclature, which is carbon. C, number of carbons, colon, number of bonds. Delta nomenclature, which distinguishes where the double bonds are, which is what all the A's here are supposed to be deltas. And omega nomenclature, which is basically you count backwards from the omega or end carbon to to the first double bond, and then that qualifies what kind of fatty acid it is. Thanks for watching. I hope you learned something, and hopefully I'll have some more of these in the future. So thank you. Like I said, if you liked it, like the video. It really helps me. Or leave a comment, something you want me to do in the future, something that's confusing. I'll try to get to it. Thanks, and have a great day.